Hello, this is a high-level overview of some of the benefits of using Kubernetes. It's not meant to be a sales pitch. A lot of people are talking about cloud technologies. When you hear about cloud native, what they're talking about is containers. And in our world, when it comes to containers, we are using Kubernetes to manage those containers. Here's the official definition of cloud native from the Cloud Native Computing Foundation. I'll go ahead and let you pause the screen if you'd like to read this. Otherwise, we're going to go ahead and move on. Some background. Kubernetes was released in 2014 from Google, and one of the earliest adopters was Netflix. Netflix was moving between mailing out DVDs and streaming online, and they needed a solution that could massively scale, and Kubernetes was that solution. What this means, though, is that they worked out a lot of use cases that we will never have to worry about because they've already been taken care of and added back into Kubernetes. So we get to benefit from all of the fixes that they put into place years ago. And recently I was in a presentation at KubeCon, and Google was there, Disney was there. They were talking about whether or not we should have stateful applications in containers or not. And that's a link that I can send out later. But I just wanted to mention it here just to build some support in the product that it may still feel kind of latest and greatest and exciting, but it has been around a while and it has solidified. In fact, a lot of our VMware environment that we are using right now is actually running on Kubernetes. You can't tell that it's there, but when we start troubleshooting with the VMware teams, we secure shell into the servers. We can see that everything's running in pods. Not absolutely everything. The ESXi servers, and I'm sure there may be some other things, are not within the Kubernetes environment, but a lot of it is. That's the direction they're going in. And it makes sense because one of the benefits of using Kubernetes is that you are able to roll up to a new version of something without any downtime. And we will come back and talk more about that a little bit later. So just a screenshot of the original release date, September 9th, 2014. And they didn't just release a product that they were using internally. They, in fact, were using a couple different products. And when they decided to release everything as open source, they built up a team, brought in experts from the two different products, took a look at things and said, what are our lessons learned that we've got here? And then rewrote the whole thing from scratch. So it's already been refined in that way. And that was the foundation that we've all been benefiting from for a while now. And I just wanted to revisit this idea of DevOps, continual improvement, the Japanese Kaizen philosophy, and say that has been applied to Kubernetes itself, and as relates to IT processes. So there's books like the DevOps Handbook on how to run an enterprise and other things, ITIL and whatnot. And the end result, which you're going to see in a little bit as we talk more about Kubernetes, is that a lot of these best practices are simply part of Kubernetes right from the beginning. For example, you'll get load balancing if you want it right off the bat. It's no longer like a special procedure to set up a system and get load balancing. But mainly, I just wanted to point out that, for example, I have a Kubernetes cluster at my house and I'm running like 16 apps, and everything it's working fantastically, and it takes up less resources. Everything seems to work faster. I'm not even sure how that's possible. And also everything has certificates. And before I was using Kubernetes, they didn't have certificates because everything has different operating systems, different apps use things in different ways, different languages want their certificates to be in different places. But because I'm using Kubernetes and certificates is something that's been solved, my environment works. So before moving on, I just wanted to say I'm not using it at my house because it's the latest and greatest and exciting, although it is. It's because it's a better system. And just to get right to it. So this isn't necessarily Kubernetes itself. Kubernetes manages containers. It load balances them within a cluster. and allows you to roll out new versions and such. But we're now talking about add-ons that the community has created, which run within the Kubernetes environment that most people end up using. And the first one, an obvious one, is the cert manager. You spin up a website within Kubernetes almost immediately. Within a minute, you've already got your certificates assigned. And when they expire, it'll automatically get new certificates. Nobody in the community within the Kubernetes world talks about certificates. I went to a conference recently, which I mentioned. If I had brought up, how do you solve the certificate issue, people probably would have just laughed at me because it's no longer an issue. It's not even a topic to discuss because it's standardized and it works. And in our environment, we're using Active Directory right now, but it supports the Acme protocol, so we can use that with DigiCert as well. So basically, if you spin something up within our Kubernetes environment, you're going to get the DigiCert certificates automatically without having to think about it, as well as your IP. So we've configured external DNS with Infoblocks, and within a minute, you've got an IP. So you spin up your website, you got your certificates and an IP, and you can immediately access the website, and it just works. So what I've been telling people as I give this presentation is that either one of these alone, even if it was just DNS, I would suggest this justifies continuing to look into Kubernetes as something we might want to adopt, at least in perhaps a small scale initially and perhaps at a larger scale later on. In this presentation, I'm mainly just going to talk about like the SRE role, the site reliability engineering. We're just talking about like deploying apps and the work of maintaining those apps. We're not even going to get into the DevOps tools that are possible, but generally developers like working with Kubernetes. So just some concepts here. The idea that's typically associated with setting up an application, you spin up a server, and the naming of the server, and the maintenance that goes along with that, patching it with SCCM or Avanti or whatever the tool is that you use, and the downtime associated with patching those products if you have to reset the machine. Just none of that exists. It's not just like the certs. You don't even talk about it. You do have the Kubernetes clusters, but they're designed for uptime, right? So if you imagine maybe 3 worker nodes and there's a networking subnet between them and they can all see that, that's where you deploy out your containers. You don't care where, you just let Kubernetes decide, okay, this worker node, it's not doing much, let's deploy it over there. And then you access everything through the FQDN. So you put in your FQDN, it hits the load balancer, does its reverse proxy, locates where the service is, and then you can access it. So when it comes to maintaining the Kubernetes cluster, you just drain one of the nodes. It'll start up all the applications that were running on that first node or whichever one you're draining on the other nodes. And when they're ready to go, then it shuts down the first node. You perform your updates or whatnot, you reboot, you come back up, and then you uncordon it, right? Like a police tape around an area. You remove that and say the worker node's ready to go, and then you move on to the next one, you drain it. And we don't at this point even have to worry about that because we have a Tanzu product. We can just say, upgrade to the new version and it will do it for us and nothing will go down. I mean, there is a possibility of something going down for a few seconds depending on the app, but that's only if you haven't configured some health checks, which is the next bullet point here. So by default, if the process running in a container such as WordPress crashes, Kubernetes will see, oh, that pod crashed, but it's supposed to be running, so we'll just start it back up. This brings up the idea of BK and AK before Kubernetes and after Kubernetes. So this is something you can do in BK world. If it's a Windows service, it'll restart the service for sure. So you get that same benefit here by default. But also there are health checks. So you can do by default maybe just like a web query, and if it responds, everything's okay. And this handles the situation. What if WordPress didn't crash? It's still running, but it's not functioning, so it's hung. So in this case, if you have the right health check, again, Kubernetes will say, oh, the health check didn't pass, so we'll restart that pod and keep it going. This can help from having some phone calls in the middle of the night because something's gone down. And later on, you can look at the statistics and see, oh, it's been restarting over and over again. There might be a problem there, but at least in the meantime, the site's still up. Next, we have load balancing. And in this case, everything within Kubernetes essentially is set up with load balancing by default. So they have something called a replica count. And by default, the replica count is 1. So by default, 1 instance of a container starts up. But you can change that replica count to 4, and it'll start up 4 containers. And it will load balance between them, right? So initially just by round robin, but later on, if you wanted to, you can change the algorithm for how it load balances between the different containers. I think there's 8 or 12. I haven't looked at it for a while. The default works for me, but you can set it up, for example, to access the container which has the lowest CPU rather than just one at a time, right? So something to look into by the teams who, we'll just say something to look into. So high availability. By default, if you change the replicate count to more than 1, you essentially have high availability. So a scenario in BK world where it would be something kind of special. If you set up the high availability, you're just going to get that by default. Of course, there's more to high availability than just more than one server running, right? The bottleneck can be at different places, such as a database, and it has to be designed in such a way as to work with multiple instances. But there's a good chance if it's running in Kubernetes that people have already thought about this situation. But in any case, default behavior. And also scaling, which is a popular topic. If you were running, say, in a cloud environment, you could set it to watch either the memory or the CPU or both. And if they go above a certain limit, you can deploy another container. And now we're load balancing between more than one. So in a cloud environment, you can scale up, right? And then when things aren't so busy, you can scale back down to save money. On-prem, you're not necessarily saving money because we're already paying for those resources, but the idea is still there. It's something that can be taken advantage of. Perhaps during um, a season when it's time to go hunting and you need licenses and the website really speeds up. Maybe that's something we could take advantage of. But in the most basic situation, this load balancing is really just a default behavior of how Kubernetes works. So if you have a container running WordPress 1.0 and you want to use 2.0, you change the definition, the YAML behind the scenes to 2.0. Kubernetes will stand up a second container for 2.0, and it's waiting for its health checks to work, but also, as you see on here, a readiness probe. So that can be not only that the WordPress site's working and that the web's responding, but also this readiness probe might be something like accessing the database that's in use. And if the database responds, then we say, okay, now we're actually ready to receive connections coming in. And the moment it's ready to receive connections coming in, it redirects automatically, Kubernetes does, and starts going to the new container. And it watches the old one. For a while, you'll be hitting both servers until the old one, all the connections go away, and you're just left with 2.0. And the same thing happens in reverse. If you release something and things aren't working like you want, you can always roll back. Just change the version to 1.0 and it does the same thing. Stands it up, waits till it's ready, then removes the second one. This also introduces more concepts of like algorithms to roll things out. So if you have 10 and you've got 10 containers running and you want to run something on a new version, you can change that and maybe just do a couple. There's algorithms to do like a couple at once until it's done, or you can do like a canary deployment, maybe just do a couple and then just wait for like a day. Make sure everything's really working before you do maybe just a couple more, right? You have options here, and it all just kind of comes built in. So it's stuff we can look into. And next I have RBAC, and I don't want to go into it too much other than to say that a lot of people have looked into this product and they've worked out all the security down to the nittiest, grittiest little thing you might want to control security access to. And I'd like to say in almost the same breath that, okay, it's great, and we do have default. We use Active Directory groups to control basic access to clusters at the higher level. But really, what we are using is the idea of GitOps, which we're implementing through Argo CD. So you put whatever it is you want to deploy into a Git repo, and then Argo CD is configured to look at that repo, and if it sees any changes, it deploys that into the environment, right? So in the Git repo, you have WordPress 1.0, it deploys WordPress 1.0. And then when you want to upgrade the version, you go into Git, You make a change to 2.0, another coworker approves the change, and then Argo CD checks every now and then. Oh, we're going to 2.0. It upgrades to 2.0 in the environment. The same thing with going in reverse. Someone makes a change in Git, and then you have a coworker approve that change, and then there you go. All right, so this this is something we can do in BK world with like a Word doc, right? Like here's exactly what the server is doing. So if later on somebody else has to tear down that server and build it back up, you have exactly what the steps are. We get that by default if everything's in Git. So once you know how to read this YAML, you can go look into Git and you can see everything that's deployed in the Kubernetes environment. So essentially a self-documenting feature if you happen to be using Kubernetes and Argo CD. And then we also get that security benefit that no one's going to go to a server, make a change that nobody knows about, and that's not recorded in the documentation. It simply doesn't happen. You go through Git if you're going to make a change. So no mysterious changes. And if somebody does go into Kubernetes and make a change with something that's set up with Git, it immediately sees that a change been made and it reverts it back to match what's in Git, which is pretty cool. Next, we have a kind of consistency. Um, and again, like some of the earlier features, I would say either one of these is like justification that we probably want to keep looking into this technology. By default, everything logs, every container, so every pod logs to standard out. And there's ways to using the command line interface to go in there and look at those logs. But what I would promote in our environment from right from the beginning is to use a tool such as FluentD here. That's the one on the left to capture those logs and redirect them to a log aggregator. So we have log insight from VMware. So just imagine if you set up 100 WordPress sites, they're all in the Kubernetes environment. 100 sites are all logging to log insight, right? So if something goes wrong, you can just go look them up over there and troubleshoot the issue without having to first access the machine. Who knows where it's running? Try to log in, maybe your credentials stopped working, right? Now we're in, whether it's Windows or Linux, where are the log files? Are they always in the same place? Well, I mean, they probably change per application, but that whole set there doesn't have to exist in an enterprise kind of environment. We could just always have the logs go to log insight. And the other benefit is like from a security perspective, right? If somebody hacks into a site and they're making changes, they're probably going to erase the logs, right? So later on when you get in there, you won't see what's going on. But if the logs are captured in a tool like Log Insight, that path will still exist. And in the same way, we have Prometheus and metrics. So apps within a Kubernetes environment, they're going to capture different kinds of statistics depending on what the app is. An app such as WordPress that we've been talking about might capture how often the site's been used. In Kubernetes, metrics are captured in a similar way, and in the same way, because of that consistency that we can capture the logs with FluentD, we can capture the metrics with a tool such as Prometheus or Datadog. There's various tools, but once they're all captured into a single location, in the same way the logs go to Log for Insight, that allows us to do an analysis. And we can pull out a tool such as Grafana, which has hundreds of graphs and that sort of thing that already exist. We can just turn one on, point to the metrics, and you can imagine having a meeting where, say, we've got 100 servers deployed out there, WordPress sites. We can pull up the statistics and see which one's been used a lot, which one hasn't been used much. And you could imagine perhaps a side effect such as, okay, the hosting team is contacted and said, we're going to increase the resources for this one particular app because it's being used a lot. So rather than a site going down in the middle of the night, you just get a phone call. Okay, the resources have been increased. Don't even worry about it. We took care of it. It's a different way of doing things. And it's a benefit we could have just by consistently doing the same steps for all apps that are deployed out into the environment. Service mesh. All right, so in the world of Kubernetes, generally you have an application deployed into a namespace. And with the namespace, you can control resources such as CPU and memory and whatnot. Because this is the way it's generally done, they have created a service mesh which can be applied to a namespace. And what this means is inside a namespace where you have microservices running, such as WordPress, maybe we got a WordPress, a Redis server, a database server. Because they're all in the namespace, the service mesh understands that they need to communicate with each other in order for the application to function. But there's no need for anything to communicate outside of that namespace. And so you can configure the service mesh to isolate that application. So this is the use case. I'll bring up my Kubernetes cluster that I have in my house again. I'm running a few apps there. I want to run WordPress and expose it to the internet. What if somebody hacks into my Kubernetes cluster through that WordPress site? Once they're at that WordPress site, can they just continue to hack everything else that's in the Kubernetes cluster and into my home network? The answer is no if you have correctly configured a service mesh, because it isolates. So that's the first use case. And then additionally, there are several providers of the service mesh. Some offer a second use case. They say because the service mesh is aware of what is communicating with what inside that namespace, they can watch that, and then later on, if something breaks, such as we can't log into the website anymore, is it because of the website, or maybe the communication to the Redis database, or maybe the communication to the other database, or the identity provider behind the scenes? It could show that there was communication happening and the communication is no longer happening. So even in a graphical way, you could help troubleshoot that issue. I'm not I'm not promising that use case. I'll believe it when I see it. Well, I mean, I have seen a demo from VMware. They pushed a button, turned a service mesh on, and we could see graphically what was in that namespace. And I was told how it would work to troubleshoot something. But we'll just put that out there as something that we might want to look into. But for sure, that first use case to be able to isolate, I would promote a policy, a procedure, a standardization that we would like to apply a service mesh to every application in the same way that we track logs and we track the metrics. Every application would be wrapped essentially into a service mesh. So if it's hacked into or whatnot, it would be isolated. And my understanding is that it takes up very few resources to do that. In the same way you might have a firewall, it doesn't take up much to have that there, and then you get that added protection. So there we are in summary. I thought about highlighting some of these items to say, these items alone might be, justification to keep looking into this product. But I'll just put it out there. In a managed Kubernetes environment, you could expect to get these offerings if you decide to deploy an application into that environment. That's it for this session. Thank you for your time and attention.